In section 5.6, we're looking at using function notation with linear models to make estimates and predictions. So in the first example, we're told that the retail sales of skincare products were 4.7 billion in 2002, and they have increased by an average of $0.23 billion per year. We want to write a function that models this situation. Okay. Now, we know that what we're going to be looking at in this section are linear models, and we know that linear models are of the form y equals mx plus b. And there's a variety of ways that we can find these models. One of the ways is if you know m and you know b already, you can use them to write the equation. Or if you don't know m and b, you should be able to find them given a couple of ordered pairs. So let's see what we have here. I'm scanning my information. I see that I have a correlation of 4.7 billion in 2002. That's probably an ordered pair. And I have increased by an average of 0.23 billion per year. Because of the word per right there, I know that this is a quotient, a division of billions of dollars per year. This is a slope value. So they're actually telling me the slope of this function is a positive 0.23. Okay. Now the other ordered pair that they're giving me is something to do with the year 2002 and 4.7 billion. Now we know that we don't like ordered pairs that have large values for x, like 2002, so we're going to want a starting year. Always make sure to check first to see if you have a starting year, and if you're not given a starting year, you can define your own starting year. So I'm going to define my starting year to be years since 2002. If I get to pick it, I'm going to pick the first year I'm given as my starting year. Okay. So we'll make ourselves a note that we're going to use t as our variable. T is going to be years since 2002. That's going to make the ordered pair 0, 4.7. All right, and because I chose 0 for 2002, the ordered pair 0, 4.7 is a y-intercept, so that means that my b value is 4.7. So if I get to pick the year, it's wise of me to choose the year that's going to give me b immediately, rather than picking a year that's going to make me solve for a different value of b. It's just faster. It's smarter to choose that value. Okay. All right. So one of my variables is t. That's my independent variable. I need a variable name. Again, oftentimes they will tell you which variables to use. This one it does not. We have to define our variables. So we're going to pick the variable name for the other value. Now this is retail sales of skincare products. So let's make this a function s of t for sales. So s of t is going to be sales in billions. Alright, so let's put the pieces of our equation together. We know that the equation would be y equals mx plus b. Y equals 0.23 x plus 4.7. However, that's just an equation, not a model, and it's not in function notation. So one more step here to get our final answer. To make this a model, we're going to exchange the letters x and y with their respective variables, t for the independent variable, and we're going to use function notation s of t for the dependent variable. So the answer is going to be s of t equals 0.23 t plus 4.7. That's the equation of the model. In part B, we're going to use our model to predict when retail sales of skincare products were 3.5 billion. 3.5 billion is our S of t value. So what I'm trying to solve for here is solve for when is t, so solve for t when S of t equals 3.5. So we're going to set our equation that we found, our model, equal to 3.5, and we're going to solve for t. So S of t becomes 3.5 equals 0.23t plus 4.7. Okay. Now, solve it, we're going to want to subtract the 4.7 from both sides. That gives us negative 1.2 equals 0.23t. And then if you divide both sides by 0.23, you'll come up with about negative 5.22 if you round the two places, equals t. All right, that doesn't quite answer the question. The question asks when. When is going to be a year value, but I know that this is the number of years since 2002, so if I add 2002 to that, you'll come up with 1996.78. Okay. So 1996.78 is still in the year 1996. It might be, October, November. It's like near the end of 96. But we have not reached the beginning of 1997 yet. So we say in the year 1996, sales reached 3.5 billion. Let's look at example 2. People who travel to mountainous areas sometimes get altitude sickness. This is caused by the fact that at higher elevations, the atmospheric pressure is lower. At sea level, with an altitude of 0, the atmospheric pressure is 29.92 inches of mercury, and it decreases by 1 inch of mercury per 1,000 feet at altitude. So we want to identify the types of information we're given. Well, once again, we seem to be given a correlation right here. We're given an ordered pair where the altitude is 0 and the inches of mercury are 29.92. So let's look at the other value in this problem. We can see that it's decreasing by 1 inch of mercury per 1,000 feet. So we see our ratio here. This is going to be a slope value. Per is a division word. So I have my slope value to be a decrease of -1 per 1,000 feet. So per 1,000 feet, that 1,000 feet is going to be part of my units here. So I need to make sure I define my variables again. My independent variable is going to be thousands of feet. Let's just go ahead and use x for that. So x is the altitude in thousands of feet. And the dependent variable is going to be the atmospheric pressure, so we'll use A. We're going to make this a function, so we're going to say A of x is the atmospheric pressure in inches of mercury. So the atmospheric pressure in inches of mercury, I just used the chemical element for mercury, Hg. You can write the word mercury if you prefer. So my equation is y equals mx plus b. So y equals -1x plus, remember that we have the b value since I have the y coordinate of the y-intercept, since I have a 0 as the x coordinate of that ordered pair. So I've got 29.92 for my b value. And that is not quite the answer. That's the equation, but it's not written as a function, and it's not written as a model, which would have the letters x and a in this case. So my model is a of x equals -1x plus 29.92. Part B. Denali in Alaska is the tallest mountain in the U.S. with a height of 20.3 thousand feet at the peak. What will be the atmospheric pressure on a mountaineer at the summit of Denali? Okay. So this is my height, this is my altitude. So I'm going to plug that into the function for x. So what we're going to be computing here is A of 20.32. A of 20.32 is -1 times 20.32 plus our 29.92. If you have a calculator and simplify that, you're going to come out with 9.6. So the atmospheric pressure on a mountaineer in the summit of Denali is 9.6 inches mercury. Those are the units for atmospheric pressure. Let's check out the next page. Example 3. The average gasoline taxes in 2010 dollars per 1,000 miles are shown below. What I want to do is look at this scattergram and explain why a linear regression would be the best way to find an equation of the model. I can see that these points are approximately a straight line, but they are not a perfect straight line, so I'm going to want to use a regression to get the best fit model. So some of the things I observed to make that conclusion are the fact that the data is approximately linear, consistently decreasing is another thing I can observe. Okay, so what we want to do now is find the regression model, so I need to put all this data in my calculator. And before I put the data in, I need to talk about years since my starting year. So let's read and just make sure that we're not given a starting year. We actually are given a starting year, 1990. So I'm going to make sure that I plug in 5, 8, 11, 14, 17, and 20 for those x values. I don't want to do the year value, and I'm not allowed to pick my starting year if I'm given a starting year. I need to use the one I'm given. All right, so let me clear my calculator, and we're going to go into the Stat menu, Edit, and we're going to enter our data. So go up and clear, and up and clear, and so we have it blank. Let's plug in our data right here. Also plug in the y values in list 2. And once your data is all in the calculator, you're going to do your regression by clicking on Stat, going over to Calculate, and selecting option 4 to do linear regression. List 1, list 2 are where you need your data to be, so just go down to Calculate and hit Enter. Alright, the A value is the slope in this case, the B value is the intercept, so we'll write these down. My equation is going to be A equals f of t equals, now my format was mx plus b or ax plus b. We're going to start with negative 0.638 times t plus 31.476. And so we have our equation. In part C, I want to find the A-intercept. So the A-intercept is going to have the t value being 0. So the A-intercept is the value you get when you plug 0 into the equation. So plugging 0 in for t makes this 0 plus 31.476 or 31.476. What does it mean? Okay, so the 0 that got plugged in for t was my time value. I'm 0 years since 1990, so that means we're in the year 1990. So in the year 1990, what's that 31 represent? So that 31 is the average amount of gasoline tax that you pay per 1,000 miles driven. So in 1990, the average gasoline tax per 1,000 miles is 31.476. It'd be alright if you rounded that to 0.48 since we know it's talking about money here. But at a gas pump, you do see the third decimal place appear in a lot of prices, so it's okay to leave it this way as well. Okay, part D. Find the t-intercept. So the t-intercept is going to have A equals 0. And so we're going to set our equation equal to 0. So 0 equals negative 0.638 t plus 31.476. Now we need to solve for t. Because the negative 0.638 t is negative, I'm going to add it to the other side. Adding it to both sides will give us 0.638 t equals 31.476. And we know that if we want to solve for t, we're going to divide both sides by 0.638. So t is equal to, grab a calculator and divide 31.476 by 0.638. We get about 49.34. Now remember that this t value is in years since 1990. So add 1990. That would be the year 2039.34, or still during the year 2039. So in 2039, what are we predicting? We're predicting that the average gasoline tax is going to be $0 per 1,000 miles. So in example 4, we have a bit of data right here, and we want to first draw a scattergram of the data. So we're going to look at t being years since 1900. So we're starting with a value of 50 for t, 60, 70, 80, and 90. So when I draw my scale for t, I'm going to go up by tens. And my scale for the population should go up by maybe 50 or maybe 100 to get all the way up there. Let's see how many tick marks we have. It looks like I'm going to have to go up by 100 to be able to get 900 on there. So let's draw those in by 100. And once you have your scale set up, go ahead and draw all of the ordered pairs in that scattergram. So once you get your data plotted, it should look approximately like this. Now, it does look approximately linear. You see the general downward trend. So we're going to be using a linear model here. In part B, we want to find the equation of the linear model. Since the data is definitely not exact, but approximately linear, we're going to use a linear regression. So you're going to go to your calculator and put all of your data in the Stat menu, Stat Edit, in List 1 and List 2, and then go into Stat and calculate option 4 for your linear regression. Okay, so our linear regression gives us the equation y equals negative 14.2 plus 1,642. Now, again, that's the equation. I want the model, so let's go look at the variables we're supposed to be using. We're supposed to be using p and t instead of x and y. So the model is the equation p equals negative 14.2 t plus 1,642 or 1,642. All right, what is the slope and what does it mean? The slope is that negative 14.2. Now, the slope is the rate of change. It's a negative value, so we have decreasing. And our units on P are population in thousands, and our units on T are years. So this means that the population is, make sure you say decreasing, by 14.2 thousand per year. Let's look at the next page. On the next page, we want the t-intercept. Let's go ahead and write that equation on the top of the page again. It was p equals negative 14.2 t plus 1,642. What is the t-intercept? The t-intercept is going to have 0 for the p-value. So we'll start solving this with 0 equals negative 14.2 t plus 1,642. And to solve, we're going to add our 14.2 t to both sides. 14.2 t equals 1642. Divide both sides by 14.2 and we'll get the t value. So our t value is approximately 115.63. What does that mean? So the t value is the number of years since our starting year. Remember that our starting year was 1900. So it's 115 years since 1900. So if we add that up, that would put us in the year 2015.63, which just means that we're in the middle of the year 2015. So in 2015, our prediction is that the population will have decreased to 0. So this is unrealistic. It's probably model breakdown, but that is what the model predicts. Anytime you get a prediction that doesn't make sense, you should mention that fact by saying that there's probably a model breakdown happening here. Estimate St. Louis's population in 2005. Okay, so in 2005, that would be how many years since 1900? 105 years. So our t value is 105. We're going to plug that into our equation. So our equation is p equals negative 14.2 times 105 plus 1,642. You can do that all in your calculator and you'll come up with the value 151. So in 2005, we estimated the population is 151,000. The actual population in 2005 was 335,000. So is our result an underestimate or an overestimate? Our result is an underestimate, being under the actual value. In part F, we want to explain why the result from part E suggests that the t-intercept we found in D is an example of model breakdown. Well, we were good about our explanation anyway, and we already mentioned that it was model breakdown, but we can also see it because we know that the value in 2005 is much too low already, so the value that we get here being 0 is probably much too low for the actual population. We have underestimates here. Now, it doesn't make sense anyway to have a population of 0 in the city, so we knew it was model breakdown to begin with. Let's check out the next example. The number of girls in millions participating in high school sports has increased approximately linearly from 1.9 million girls in 1990 to 3 million girls in 2004. Predict in which year 3.5 million girls will be participating in high school sports. So the information that we are given here is a pair of correlating data points, so a pair of ordered pairs. And we get to write our own ordered pairs. No starting year is mentioned, so we're going to be able to choose our own starting year. So let's say let X be years since. Now you can choose any starting year you'd like. You can choose 1990, 1900, 2004, 2014, whatever year you want. But it's always a really good idea to pick the first year that you're given, because if you choose your starting year to be that year, you're going to already know your y-intercept. So if X is years since 1990, the first ordered pair is 0, 1.9, and the second ordered pair is 1990 to 2004 is 14 years, so 14, 3. Now, like I said, since we chose our starting year to be one of our year values, we already know the y-intercept, or the b value for the equation of our line. The b value is going to be 1.9. We don't know the slope value, but since I have two ordered pairs, I can calculate the slope. So let's do that next. We know that we calculate slope by y2 minus y1, so 3 minus 1.9, over x2 minus x1, so 14 minus 0. If you simplify this, you're going to get about 0.07, I'm going to keep 4 places here, so 0.0786. The equation of my line now is y equals 0.0786 times x plus 1.9. Got my slope, and I have my y-coordinate of my y-intercept. I did say x was going to be years since 1990, so I already have my x value. We could choose a different letter for y. Y is the number of girls in millions, so I could say G for girls to make this a model in terms of these variables. Alright, so the goal here was not just to find the model, which I had to do, but also to predict during which year I'm going to have 3.5 million girls participating. So I'm going to plug in 3.5 for G and solve for X. To solve this equation, we're going to be subtracting 1.9 from both sides to start. That gives us 1.6 equals 0.0786x. And then if you divide both sides by 0.0786, we'll come up with about 20.36 for the x value. Now don't forget that this is years since 1990. So we're going to want to add 1990 to that to find the actual year. 1990 plus 20.36 is 2010.36, or in the year 2010. So my final answer here is going to be in the year 2010. We have about 3.5 million girls participating in high school sports. Okay, let's go on to the next example. Example 6, the percentage of Major League Baseball players who are African American has declined approximately linearly from 17% in 1997 to 8.4% in 2006. This equation is very, very similar to the last one. I have two ordered pairs here, and we're not given a starting year, so we get to choose our starting year. Let's let our starting year be the first year we're given. So X is going to mean, if you ever choose a starting year, you have to write down and declare it, otherwise no one knows what you picked. So X is going to be years since 1997. Okay. That's going to make your first ordered pair 0, 17, and your second ordered pair, 1997 to 2006, is 9 years, so 9, 8.4. You always want to pick, if you're allowed to pick, if you're not told starting year, you want to pick the first year because you know the b value that way. That is a y-intercept. The b value is 17. And now I need to calculate the slope. So we calculate the slope, y2 minus y1, 8.4 minus 17, over 9 minus 0. If you use your calculator to simplify this, you're going to come up with about negative 0.95 0.55 repeating. So if I keep 4 decimal places, it'll be 0.556. Okay. So the equation is y equals negative 0.9556x plus 17. Now, since we're talking about percentage, I can call it p instead of y. If I want to put this in function notation, I could even call it p of x. Let's go ahead and write it this way. The goal here wasn't just to write the equation. The goal here was to solve the equation for a value. So they didn't tell me how I had to write it, but it's always a good habit to put it in terms of the original variables. And let's get in the habit of writing things in function notation as well. What do I want to do now? Predict when 4% of the players will be African American. So we're going to plug in 4 for the percent for p of x and solve. So 4 equals negative 0.9556 x plus 17. Solving for x, your first step is going to be to subtract the 17. That gives us negative 13 equals negative 0.9556 x. And then if you want to solve for x, you're going to divide both sides by that negative 0.9556. So I come up with about 13.604 equals x. Now go back and think about what year you chose as your starting year. Remember, we chose 1997 to be our starting year. So we're going to add that to 1997. It's going to give us the year 2010.6. So our prediction is in 2010, there were 4% of baseball players were African American. And that's the end of this section.